Okay, first term of geometric progression is 50, so that's A. Common ratio, that's R, is 0.8. Use logarithms, and that means use logarithms. If I don't use logarithms, I won't get the marks. In fact, the maximum I will get is actually only 1 mark if I don't use logarithms to find the smallest value of k, such that the kth term is less than 0.15. Okay, it's geometric progression. Formula sheet, you might well know them, but at least open your formula sheet. I'll paste them in up here to start with. And now we can go. Right, so part A. Actually, A and B means that normally the B part doesn't refer back to the A, so we'll see what happens there. And I've got to find the kth term. So I know that the nth term is A r to the n minus 1. So there'll be A r to the kth term will be k minus 1, and that is got to be less than 0.15. And now I've got to just solve that. So it's 50 times by 0.8 to the power of k minus 1 has got to be less than 0.15. I've got to use logarithms, so I'm going to have to log it, but at the moment I've got this 50 acting as a buffer, and if I need to log this to bring the power down, I need to get rid of the 50 to start off with, so I'm going to divide through by 50 first, and that'll just give me 0.8 k to the minus 1, and that's going to be less than 0.003. And now this has got no buffer, so then I can just log that. When I log it, that means that the power bit will come down, but I'll write it down first. Log 0.8 k minus 1 is less than, and log of 0.003. That's important. That's why I like this step, to make sure I do log both sides. Quite often people can forget to log the right hand side. Now I can bring the power bit down, so I'm going to bring the power bit down, rules of logs, and that will give me that k minus 1, and put it in brackets because it's the whole of k minus 1, times by log 0.8 is less than log of 0.003. Divide both sides by log of 0.8, and that'll be k minus 1 and that'll be log 0.003 divided by log 0.8. But when I divide by log 0.8, that bit, it doesn't look negative, but it is actually negative, and since it's negative, that sign has to swap. So I get k minus 1 is greater than 26.033. Add 1 to both sides. K is greater than 27.033, and therefore the kth term, k equals 28. And that does part A. I'll do part B here. In a different GP, okay, so that's why it is B, doesn't refer to the previous bit. Second term is -3, so that means that AR equals -3, and the sum to infinity is 4, so sum to infinity is here, so it says that A over 1 minus R is 4. Show there's only one possible value of the common ratio, and that's R, and hence find the first term. So I've got to solve this. I've got two equations, two unknowns, so I'm going to work out what A equals. 4 times by 1 minus R, and then substitute that in there. I don't like that, so I'm going to put down A equals 4 minus 4R, and then I'm going to sub that up into here, and that will give me that 4 minus 4R times by R equals -3, and that'll be 4R minus 4R squared equals -3, and I'm going to I like positive R squared, so I'm going to add R squared to both sides, so I'm going to get 0 on the left hand side, and that'll be 4R squared. I've got to take away 4R from both sides, and that'll be -3 here. So I've got it like that, and now I'm going to try and factorize this, and that will give me, I've got to get a 3 and a 1, and this one's going to be positive and one's going to be negative because it's -3, and I could get 4, no, I think it's going to be 2R, this is 2R, both of them are going to be 2R, it'll give me 4R squared. 2r times the 3 will give me 6r, and 2r times 1 will be 2r, and that will end up giving me 4r's, and I want it to be negative, so that's going to be there, negative, and that's going to be positive. Just check 4r squared minus 6r plus 2r, that's good, and then minus 3, marvellous. And now we've got either 2r plus 1 equals 0, or 2r minus 3 equals 0, and that's because something times something equals 0. Solve these. 2r equals negative 1, so r equals negative a half, or 2r equals 3, r equals 1.5, but it can't. And it can't because sum to the infinity exists, and that says that modulus of r has to be less than 1, so it can't be that. So r equals minus a half, and we know that ar equals negative 3, so we've got a times by negative a half equals negative 3, and I'm going to times both sides by 2, so that'd be negative a equals minus 6, and therefore a equals 6 as my answer. And I have shown there's only one possible value, and I've put that bit down. That's important, and I have found the first term, and that's question 8 done.